We continue to the right forward fuselage, where you will see the first officer in the cockpit working hard on your departure.
Or having a small talk with the new cabin attendant.
But what is more important, Douglas, now, are the probes, sensors, ports, vents and drains again. Make sure that they are clean, that the covers are removed and that there is no damage. Very important is that you check the emergency window handle is flush with the surface. Let's continue with the right wing root and the lower fuselage. Make sure that the ram air inlet deflector door is extended and the air inlet is open. The air inlet deflector door makes sure that ice, rocks and other unwanted material do not go into the ram air inlet. The packs and the pneumatic access doors should be secured. Check at the bottom of the aircraft the condition of the water drain masts. But be careful, it might be hot. The drain masts have integral electric heater elements. Heat to the masts is constant and automatic when power is on the airplane. It operates in 115 volt in flight and 28 volt on the ground. It uses a reduced voltage on the ground to prevent burn hazards to our personnel. Also, it extends its service life. The alternate static port shouldn't be blocked.
What color should the oxygen discharge disc have?
The oxygen discharge disc is green, and if it's discharged from overpressure, it won't be there. Check the condition of the leading edge flaps and exterior lights. We continue with engine number 2. On every side you verify that the condition of the cowling, fan cowl, vortex control devices is good and that the access panels are latched and secured. Make sure that the thrust reverser is stowed. If you see a red screw sticking out of the engine cowl, then the thrust reverser on that side is deactivated. Let's look at the engine inlet. Inspect the fan blades for any damage, obstructions or FOD. In freezing conditions, make sure that the fan turns freely by moving it. Now check the sensors.
What kind of sensors do we have?
You will find the T12 sensor at the 2 o'clock position. This sensor measures fan air temperature for the PMC. Sensor T2 is at the 10 o'clock position, which measures inlet air temperature for the MEC to provide high or low idle power depending on aircraft situation. Make a complete circle around the engine and make sure that there is no oil leak.
And don't forget the bottom.
At the tail section, visually check the tail cone, exhaust area and the exhaust tail plug with the exhaust case struts and visible turbine blades and the fourth stage of the blades from the low pressure turbine. Make sure that there is no damage and evidence of metal or oil accumulation. Now we come to the right wing and the wide leading edge. Make sure that the access panels are all latched and that the fuel measurement sticks are flush with no visible leaks. By the way, you have 6 at each side and 4 in the center tank. Check the condition of the leading edge flaps and slats. You check the fuel tank vent by checking the ram air vent scoop for any obstruction. Make sure that the flame arrestor pressure relief valve poppet is flush. We continue our walk around via the leading edge and wingtip to the trailing edge. Look at the condition of the strobe and position lights. If the position lights are red, you did the walk around in the wrong direction.
Is there any difference between our Boeings?
Yes, there is a difference between our 300 models, with winglets and without. For the aircraft without winglets, at least 2 dischargers are on each wing, so maximum of 6 static dischargers may be missing. For our aircrafts equipped with winglets, a maximum of 2 static dischargers may be missing without any penalty. At least 1 is required on each wing.
Where there is only 1 on a wing, it must be in the outermost trailing position.
As you walk under the trailing edge of the wide wing, check the aileron, its tab, the outboard and inboard flaps, the flap fairings and the landing light in the outboard flap fairing.